This is the video for the Markov Chain program's routines. Here's where the program gets its data. First, it wants to know what the row count is, and here a 5 was entered. Here's where you click to start the process, so it'll start finding the steady state. And below that, this is where you enter the data. It says the row count is 5. So we see there are 5 rows. And since this is a transition matrix, that means it must also have 5 columns. Being a transition matrix means that the sum of the values in the rows must add up to 1. Well, let's see. It starts out here. This one is 0.97. This one is 0.03. The rest are zeros. Well, that adds up to 1. The next one starts out 0.02, 0.95, 0.03. That adds up to 1. The next one, 0.02, 0.95, 0.03, adds up to 1. The fourth row here is 0.5 plus 0.5 equals 1. And the last one is easy. We don't have to add anything up because it has a 1 and all zeros. That means anytime it comes into this state, it's always going to go back to the first state. Alright, that's our transition matrix. Well, it allows you to see the value after it's at the 2nd power, the 4th power, the 8th power, the 16th power, and so forth. Here is the answer at the 128th power. This multiplied by itself 128 times. But it didn't do it that way. It squared it, and then it made it to the 4th power, the 8th power, and so forth. This is the 128th power. If we take a look at it, this lowercase f means 6 decimal places. So this value here is 0.4337. Well, the next one is 0.4335. So it hasn't reached the steady state to the 4th position yet, but it's pretty close. The next state starts out again with f, 6 decimal places, 0.342. And all of them are 0.342, but again, after that, the next digit isn't the same for all of them. Then here's state 3. It has an F, so it's also 6 decimal places, so it's 0.205, and they're all 0.205, except in the next digit they change again. And here's the 4th state. It's a G. That's one more decimal place than it shows positions, so this is 0.0123. Well, they're pretty much alike until the 4th digit also. And here's the last state. There's the G. So this one here is really 0.006, and this is 0.006. Notice this is an H. So this 128 power is, well, maybe acceptable as the steady state. We notice that they're pretty close to being equal in the columns. Well, now we'll look at how the Markov chain program worked. This program does it the hard way. It's going to show you that it's multiplying the columns of the matrix by the row of the matrix to get each value in the next power of the matrix. That's matrix multiplication. But in this program, when it uses the mul multiply list instruction, it's going to show you a row and a column. Well, it needs to get the column data sequential. So it's going to use this action, rcol, which means change a column into a row. It's going to do it for all possible 12 rows. Here we see we only have 6 of the possibilities, but down here, this is the first one down here, row 1, starting at offset B. That B indicates which power it's at. Over here we're going to see it adds 20 to B each time. So let's understand this. What's going to happen is it has 12 names, row 1 to row 12. When it wants to look at a column then, it has to get a value from each one of those 12 names. Well, those names are stored in memory 10,000 apart. That is, row 1 can have 10,000 values. Row 2 starts exactly 10,000 values away. So what it's doing here to get the columns, and these are where it puts the columns, it starts at row 1, the first position, and then adds 10,000 to get to the next position for the column. So it's going down the column. And it's storing these each 20 apart. Notice 0, 20, 40, 60, 80. So the columns are offset 20. Now we'll go over to this routine. It's a routine where it does the multiplication. Starts out here with J equal to 0, K equal to C, and then it says for I of 1, down here next I, the row count. So it's going to go around here the row count time, which for us over here we know is 5. Each time it goes around, it's going to take the work row at offset J, which is always started at 0, and then it's increased by 20. Well, we know from over here, that's how far apart they are, 0, then 20. But it multiplies it by row 1 at offset A. Row 1 is going to have row 1 for all of the powers. The first power is at row 1, but 20 offset from there is the second power, and 20 from that the next power, and 20 from that the next power. And down here we see it's going to go around 14 times. There's going to be 14 row 1s, each 20 offset apart. So it multiplies it. Then it says it doesn't even need hold row. It only wants the value of the sum of those products. That's matrix multiplication. So the next thing it says is row 1 at offset K is set to the sum of the values in hold row. When multiply list is run, it always puts the sum of the answer into control register K. So this is the sum being put into position row 1 at offset K. Well, that value of K we see up here was started at C. And we're going to learn down here that C is always 20 greater than A. So the answer for this is going to be put at offset 20 from whatever this one is. It's going to be the next row 1 numbers. Alright, so around here it's creating a new row 1. The next one is creating a new row 2. And there are 12 of these. I told you this guy's doing this the hard way. There are 12 of these for each one of the possible row counts 1 to 12. Alright, so this is where it's doing the multiplication of rows times columns and creating one value as the answer. Here is where it raises it to the power. It sets A to 0, B to 0, C to 20, because C is going to be the next one, which is offset 20. Then it says for F of 1, and down here to F of 14, it's going to go around and square the matrix 14 times. Here it says, go to A, AM. These routines that we just went over are in that subroutine at AM. When it returns on A. So at the end of this routine, there is a return on A. Then it comes back here, adds 20 to A, 20 to B, and 20 to C, and then goes around this 14 times. So it raises it, squares it 14 times. We only looked at the 7th one here, 128 power. Alright, this is the routines for the program Markov Chain.